All right, a compound. Yeah, it's not just, though, a combination. We can't just say a combination of two or more elements. I mean, we can, but we got to be more specific. So if I take tin and iron, and I just pour it together in a beaker, I'm combining them. Are they making a compound? No. Right, chemical compound. So chemically combined. So two or more elements chemically combined. Chemically combined. Two or more elements chemically combined. All right, that's the key. Chemically combined. Compounds. Do they have uniform composition? Look at our notes. Elements are substances. Compounds are substances. What is the one sentence or the one note that we took yesterday under the word substance or pure substance, whatever I wrote? So we wrote substance, then underneath we wrote something. Go ahead, Max.
They are uniform.
Right, substances are uniform in composition. Did we write anything else? That was it? Okay. Uniform, yeah, so compounds are uniform. Here's an example. This is salt. I keep using the same one, but it's because it's here. Okay, uniform. Every part of this salt is the same. If I gave each one of you a little pile of salt and I had a little pile, it'd all be identical. It's uniform. So, compounds are uniform. I'm not going to write it. We already did. Can you break a compound down into something simpler? Yes, what can you break it down into? The elements that make it up. So compounds can be broken down. But how? Chemically or physically? Chemically, yeah, you can't take a really sharp knife and slice through the air and then CO2 breaks apart and the carbon just starts falling out of the sky. Okay? It doesn't work. Okay? You can't do that. So it can be broken down chemically, and that term is called decomposition. In chemistry, decomposition means breaking a compound down. I'll give you an example. If we take salt, NaCl solid, draw an arrow. If we, well, this isn't so simple, but if we put ELC, electricity, you know what? Instead of solid, let's use a liquid. Sorry, you're using pen. Sorry about that. So if you have liquid salt, which is called molten salt, it's just really, really hot, actually about 801 degrees Celsius is what it takes to melt salt, because salt's wicked strong. What's that mean? Strong forces that hold it together. So if you have liquid salt, you run electricity through it. It's called electrolysis. You can actually get sodium metal and chlorine gas. Solid sodium and chlorine gas. Remember, chlorine's a honkobriff, so it's Cl2. Anytime a honkobriff is on its own, it always gets that little 2. In a compound, it may or may not get a 2. I told you in lab where that comes from with the charges and everything. So anyways, this is decomposition, okay, when you break a compound down. And we actually would have to balance it. We need 2 here and 2 here. And if that's confusing, that's okay. We'll talk more about the big 2's down the road. Those are called coefficients. It's so we have the same number of atoms on both sides. 2Na, 2Na, 2Cl, 2Cl, everybody's balanced. We'll do that down the road. But anyways, that's what I mean by chemically broken, using electricity or something to that effect. Decomposition, heat, using heat to break something down. Okay. All right. Compounds always form in the same proportion. Always form in the same proportions. What does that mean? It means water is always H2O. It's not like you go to a different country and water is, H1.506. That doesn't work, okay? Water is always H2O. H2O, it's never anything else. Carbon dioxide is always CO2. The name or the symbol here, the formula, never changes. So compounds always form in the same proportions. However, there's a little caveat, there's a word? Little trick to that, sort of. Let me explain. So they always form in the same proportions, but we're good here? Max, you good? always form in the same proportions, but compounds can form in multiple proportions. What? That makes no sense. I just told you it always forms the same proportion, and now I'm saying it form in multiple proportions. Let me explain. Nitrous oxide versus nitrogen dioxide. These are just two examples. Some of you may have heard of nitrous oxide. Nitrous is what people call it. Anyone know what it does? Shane knows?
Very, very fast.
Yeah, it makes cars go real fast. Okay. Nitrous oxide is N2O. That's the chemical formula for that compound, N2O. Nitrogen dioxide is NO2. So, let me explain. If you have a container or a tank full of nitrogen dioxide, whether you're here or in Canada or in Asia or Hawaii or your own house, wherever you are, if you have something labeled nitrogen dioxide, this is the chemical formula for nitrogen dioxide. It cannot change. That's what I mean by it forms the same proportion over and over. However, when nitrogen and oxygen react and form compounds, they can form compounds with different proportions. So this can exist. Nitrous oxide is not the same thing as nitrogen dioxide. It's N2O, so the proportions are flipped. This is a 1:2 ratio. This is a 2:1. So the ratios and the subscripts can change depending on the compound. That's what that means. So you could take two elements, N and O, or H and S, or C and F, or whatever. You can take two elements and form compounds that have different formulas. All I'm telling you really, or what I'm explaining is the laws of a compound. So nitrogen dioxide is always NO2, forever and ever. But it can also form nitrous oxide, which is N2O. That's what that means. So the multiple proportions means it can change, but then it turns into something new. All right, so this is always the formula for nitrogen dioxide, but it can form that formula as well. That's what those two mean, okay? If you read that in the book, hopefully I was clear. Hopefully I was trying to help with the explanation there. If you read that stuff in the book, it's super confusing, okay? They call it the law of multiple proportions, and they go on, and I think it's confusing. So hopefully I made some sense there. All right. And the last thing here with compounds, I need a little more space. This is probably the most important to really understand what happens when compounds form. Compounds have properties that are different, underline the word different, than the properties of the elements that make it up. Compounds have properties that are different than the properties of the elements that make it up. Sometimes I think of kids when I think of this. Anybody want to take a guess as to why I think of kids? I tend to think about people as much as I can to relate to what we're learning. How are kids formed? Well, there has to be reproduction at some point there, right? So you have two parents, and then the baby pops out 9 months later. The baby has different properties than the parents. Similar because they're from the parents, but different. You're not identical to your father or mother. That's impossible. Your genetics are a mixture. So the point is, you take two elements and you put them together. It's not a great analogy, but you come together and you make something different. something new that has different unique properties. So let me think of another example. Sugar. Sugar's a compound. What's the chemical formula for sugar? Okay, sucrose. Or how about glucose? Marcy. Good, that's glucose. C6H12O6. So I'm just going to put that over here. C6H12O6. That's glucose. I want sucrose. Sucrose is two glucose molecules put together using dehydration synthesis. What? Oh, that's just blew up. What does that mean? Think about it. What's synthesis mean? To make. Or in chemistry, when I say synthesis, I want you to think put together. That's what synthesis means. Put together. You are making something, but think put together or combine. So if I take two glucose molecules, two of these, combine them chemically, and dehydrate it. What's that mean? Take water out. So let's think about that. If I take two of these, let's add those together. So add those together. What do we get? C12H24O12. Okay, that's combining. That's synthesis. That's our synthesis part. Dehydration. Let's subtract an H2O. What's my formula going to be? Because this is combining two and then taking water out. Dehydration synthesis. C12, that doesn't change. H22. Oh, what? 11. We're taking one oxygen away. We're taking two. That's the formula for sugar. C12H22O11. That's how we get sucrose. Dehydration synthesis of two glucose molecules. Molecule. What's a molecule? I say that word a lot. Is this a molecule? Is this thing a molecule? What's an atom? Sorry? What's an atom? No one knows what an atom is? I'm sure you've heard that term. You've heard me say it. No one knows how to describe it. It's the simplest part of an element. It's the smallest part of the element that retains properties of that element. So like a little ball, a little sphere. So what's a molecule? Two of them combined. Okay, I showed you with this thing, or these things. Both of these are molecules. This has 3 atoms, this has 5. These are molecules. 2 or more atoms chemically combined as a molecule. So that is a molecule. How many atoms are there? 33 plus 12. What is that? 45? Okay, there's a lot of atoms there. That's a molecule. So, anyways, back to this. Sugar. Give me the properties of sugar. What color is it? White. What physical state? Solid. How's it taste? Sweet. It's actually low melting point. Easy to melt. You can melt sugar in a pan on your stove. Let's talk about carbon over here. This carbon right here, what color is it? Carbon's black. Anybody want to taste that?
No.
Guess how it tastes? Terrible. Tastes bad. What physical state? It's black up there. What physical state? Solid. What about hydrogen? What physical state is it in? Hydrogen is a gas. It's colorless. Doesn't really have a taste. And hydrogen's flammable. Oxygen basically has the same properties. Gas, colorless, flammable, tasteless. What am I trying to explain based on this up here? What am I trying to show you? Slade.
The elements don't have the same properties as your compound.
Right. The compound sugar is white, solid, sweet. Carbon, black, solid, tastes like crap. Hydrogen, it's a gas. You can light it on fire. It's flammable. colorless. Oxygen, the same. When you combine them chemically, the properties change into something new. That's what chemical changes do. They change the properties, the composition. Okay? So sugar and these three are examples of what that means. Okay? All right. That's all the time I have. You do have homework out of your book. Here we go. Yes, I know the phone's ringing. I don't have time for the phone. Okay, and I will text it today. I apologize yesterday. Page 90. I'll write it up here, but I'll transfer it there. 24 through 27. Page 95. 65. Oops. That's 16. 65 through 71. And 73. And then page 98. 3, 6, and 7. So that's on elements and compounds mostly. So that's going to be due tomorrow. And that's it. Tomorrow we're starting